Welcome back, guys. All right, so we are continuing our unit on polynomial functions, and we're working on something called the factor theorem. So the factor theorem is all about how do we factor polynomial functions. Now, again, you have experience factoring quadratic functions, which are degree 2 polynomial functions, but you really don't have much experience doing, degree 3 or degree 4 or any higher degree polynomials as well. So we'll learn how to do that in this unit. So I always like to start this unit off by something very, very simple and saying, how do we factor the number 30? Now, I'm going to do this in a quite long and drawn-out process over here, but then we're going to apply this method to more difficult questions. So I'm going to say, question 1 is 5 a factor of 30? Okay, and hopefully we all know that the answer to that is yes. Okay, but looking at this a bit more in a bit more detail here, say when 30 is divided by 5, the remainder is 0. Okay, now, 30 divided by 5 equals 6. That means the quotient is 6, but the remainder is 0. If I say, is 4 a factor of 30? So if you think about that for a sec, and hopefully say the answer is no. Okay, so when 30 is divided by 4, we get 27. So 30 divided by 4 is 7 with a remainder of 2. So what we're trying to get out over here, if p of x is divided by x minus b, and the remainder is 0, x minus b is a factor of p of x. So this is really what we're talking about, the factor theorem. We'll talk about a bit more detail over here. Okay, so over here, so yes, we know that 5 is a factor of the number 30. Okay, and we know that because when we divide 30 by 5, the remainder we get is 0. Okay, so if I have the number 30, we know that 5 is one factor. Well, how do we figure out the other factor? To get this number here, 30 divided by 5 equals 6. So if I know that this 5 is a factor of 30, well, if I go 30 divided by 5, it gives me 6, which is the other factor. Now, guys, I know this is a very trivial example over here, but we're going to apply this method to more complicated questions. Okay, so in other words, the quotient is 6. Now, we're not done yet because I can still factor 6 down to 3 and 2. So 30 equals 5 times 3 times 2. This is what we call the prime factorization of the number 30. Okay, so again, factoring means to be able to take something and write it as a product of different things. Okay, so 30 is 5, 3, 2. These are all prime numbers. So this is the prime factorization of the number 30. Okay, so the factor theorem. All right, so what this says over here, x minus b is a factor of p of x if the remainder is 0 when you go p of x divided by x minus b, okay? Or here's another way of writing this. So we talked about the remainder theorem. So we know that if you're dividing p of x divided by x minus b, if you take that b value and put it in for the x's, that gives you the remainder. Well, if that remainder is equal to 0, that tells us that x minus b is a factor of p of x. Okay, so this is what the factor theorem says. So for example 2, we say what are the potential factors of x cubed plus 2x squared minus 4x minus 8. So what we're trying to do here, when we say potential factors, we're trying to break up this polynomial into 3 factors like this, where it's going to be x times x times x to give us this x cubed over here. Okay. Now the question is, what might these guys be? Okay. And over here, we're talking about potential factors. So my question is it possible for this guy to be a 5? I'm going to say no. Okay, it can't be a 5 because there's no way I can multiply 5 times another whole number times another whole number to get an answer of negative 8. I can't multiply. So in other words, 5 is not a factor of 8. Is it possible for this guy to be a 2? Sure. Okay, because this could be a possible factor over here. So it might be x plus 2 times x plus 2 times x minus 2. I'm not sure if it is or not, okay, but it might be this guy over here, okay? So in other words, x plus 2 and x minus 2 are potential factors. So the idea is over here, now it could be a plus or a minus. This x plus or minus 1 are potential factors, okay, because 1 is a factor of 8. So in other words, if I come back to this guy over here, like this is a possible factor, x plus 1, okay? Is it possible for this to be an x plus 4? Sure. Is it possible for this to be an x plus 2, okay? So x times x times x would give us x cubed. 1 times 4 times 2 would give us, oops, sorry, I'll make this guy negative 2 over here. This would give us a negative 8, okay? So in other words, these number here, they all have to be factors of 8. Well, what are my other factors of 8? So we said it could be positive or negative 2. It could be positive or negative 4. It could be positive or negative 8. Okay, so I'm going to say there's really 8 factors here because it could be x plus 1 or it could be x minus 1. It could be x plus 2. It could be x minus 2. It could be x plus 4. It could be x minus 4. It could be x plus 8. It could be x minus 8. The integral zero theorem. Okay, so what's this say? The integral zero theorem says if p of x is divided by x minus b, the potential, and again I'm putting this in underlining, potential b values are factors of the constant term of p of x. So for example, if p of x equals so if I'm trying to think what are the potential factors for this guy, well, x plus 1 is possible because 1's a factor of 5. X minus 1 is a potential factor. X plus 5 is potential, and so is x minus 5. Okay, so these numbers 1 and 5 are the factors of 5, and we have to include the positive or negative ones. Okay, so what this saying is the potential b values for x minus b have to be factors of this constant term right here. So I'm going to put our potential Okay, example 3. How do we factor this guy? So we're going to start is we want to get this guy into 3 sets of brackets like this. So we're going to be able to factor this guy all the time. It might not be possible, okay, to get all 3. It might not be possible to factor this guy at all, okay? But here's how we check. First of all, we're going to list out the potential b values, okay? So what we saw in the integral theorem that are before is what's the constant term? The constant term is 15. So what are my factors of 15? 1, 3, 5, and 15. Those are your potential b values, okay? So your potential integral zeros. So what we want to do is we want to figure out, well, which one of these, when you divide the polynomial by these x minus b terms, which one gives a remainder of 0, okay? So next we want to figure out, well, what's p? So let's test. Let's go ahead and let's test p of 1, okay? So if I do p of 1, I get 1 cubed minus 1 squared minus 17 times 1 minus 15. 1 minus 1 is, so this is 1 minus 1 minus 17 minus 15 equals negative 32, okay? So pretty much p of 1 does not equal 0, therefore x minus 1 is not a factor, okay? So we have a bit of guess and checking to do here, okay? So we tried positive 1, let's try negative 1. P of negative 1 equals negative 1 cubed minus negative 1 squared minus 17 times negative 1 minus 15 is negative 1 minus 1 plus 17 minus 15. Negative 1 minus negative 1 is negative 2, plus 17 is 15, minus 15 is 0. Okay, so what's this tells us over here? This tells us that if this polynomial is divided by x minus negative 1 or x plus 1, the remainder is 0. And what we saw before, if the remainder is 0, it tells us that the smaller term is a factor of the bigger term. Okay, so what this is telling us is p of negative 1 equals 0, therefore x plus 1, because that's x minus negative 1 like this, is a factor. Okay, so if I'm trying to factor this guy, we know that x plus 1 is one factor. Okay, well, how do I figure out the other factor? So if you remember back to this slide, if I knew that, so right now we're here, we know that 5 is a factor of 30. Okay, so in other words, we know that x plus 1 is a factor of our polynomial. How do we figure out this factor? Well, if I go 30 divided by 5, it gives me 6. Okay, so the quotient 6 is the other factor. So what I'm going to do here is I'm going to divide my polynomial by x plus 1 to give me the other factor. I have synthetic division to help me out with that. Okay, so if I know my b value is 1, I'm going to place in my coefficients here and follow my synthetic division rules. Okay, so what this tells us, this is x squared minus 2x minus 15. Okay, so if I'm trying to factor this guy, so far I have x plus 1, that's this factor here that we determined. And now my other factor is x squared minus 2x minus 15. Okay, I can factor this. This is now just a quadratic factor over here. I can factor this further. So if I have x plus 1, then this guy factors to x minus 5, x plus 3. Okay, so this would be my full factored version of this guy over here. Okay, next example. Step 1, by potential integral zeros. Okay, R. What are my factors of 24? I have plus or minus 1, plus or minus 2. We have a whole bunch of potential factors here. 4. So these are all of the factors of 24. Okay. Now, if you look at this, this is 16 numbers. We're not going to have to test 16 different numbers. Typically, when we do this, guys, it's going to be you test, 1, 2, maybe 3, and one of them is going to give you an answer of 0. Okay. So when I'm marking these guys on a written response question, I need to see this step. So this is telling me that you understand what the integral theorem says. So I need to see this step. Okay. Step 2 is when you start testing. Okay. So what I'm going to do, I'm just going to go ahead and do this on my calculator. Okay. So let's test 1. So I go 1 cubed plus 1 squared minus 14 times 1 minus 24. Well, this equals negative 36. I'm looking for an answer that gives me a remainder of 0. So this one does not work. Let's try 2. 2 cubed plus 2 squared minus 14 times 2 minus 24 equals negative 40. Let's try P of 3. Still didn't work. Let's try P of 4. This one does equal 0. Okay, so I just did all this on my calculator over here. So when I did this, I was putting a 4 in for the x's here and seeing what answer I got. Now, if I get an answer of 0, which is the remainder, based on the remainder theorem that we learned in our last topic, so therefore, x minus 4 is a factor. Because when I'm marking this stuff, I need to see this statement over here. If I don't see it, I'll take off a mark, unfortunately. So this is telling me that you understand that if the remainder is 0, the term is a factor of the polynomial. Okay, so I need to see this step as well. Okay, so this guy over here, I don't necessarily need to see all this work over here. Okay, you can just kind of do this on your calculator. You don't need to write it down, but I do need to see if P of 4 equals 0, therefore x minus 4 is a factor. Okay, so my next step I need to do, if I know that x minus 4 is one factor, what's the other factor? Okay, use our synthetic division step. We have 4. Okay, and the 1 comes down. Okay, so we get x squared plus 5x plus 6. So I get x minus 4 is one factor, and then I get x squared plus 5x plus 6. Okay, now I can factor this guy further. So this is x minus 4, and then I get x plus 3, x plus 2, and this is my fully factored version of this guy over here. Okay. All right. So what are our steps? Step 1 is we need to list our potential zeros up here. Okay. So you need to see this step. Step 2 is you want to start testing these zeros one by one until you get one that gives you a remainder of 0. So in this case, it took us 4 guesses. We finally got P of 4 equals 0. Therefore, x minus 4 is a factor. Okay. I need to see this step and this step for full marks. Okay, so you need to write this down on your paper. Next step is synthetic division. Okay, so this would be like 1 mark, this would be 1 mark. The synthetic division over here would be half a mark, and then fully writing out your factor will be half a mark as well. So typically, if I ask you to factor this polynomial expression over here, it would be using this method over here. Okay, so mark here, half a mark, for a total of 3 marks, and hopefully you guys are all getting 3 out of 3 on this question. Okay, all right. Example 4, x to the 4th minus 17x squared plus 16. Okay, so like we saw before, our potential integral zeros are plus or minus 1, all the factors of 16, which is our constant term here. Okay, so this is, if we write this, that's 1 out of 1 for this part right here. Okay, so make sure you're doing this part. Step 2, let's start testing them. Okay, well, what's p of 1? We get 1 to the 4th minus 17 times 1 squared plus 16 is 1 minus 17 plus 16 does equal 0. So p of 1 equals 0. Therefore, x minus 1 is a factor. Okay, I need to see this as well. Okay, next mark, synthetic division. Now we need to remember for synthetic division here, we need to remember to put in our zeros here. So there's no x cubed term here. It goes from x to the 4th to x squared. So we need to put a 0 placeholder in for that x cubed term. And same thing, there's no x term here. So we need to put a 0 in for that one as well. Synthetic division. 1, multiply, add, multiply, add, multiply, add, multiply, add. So what we have so far is we have x minus 1, we have x cubed plus x squared minus 16x minus 16. Okay, so here's our so far. Okay, now, well, this is still a degree 3 polynomial. Okay, so I'm going to do the same steps again. What are my potential integral zeros? Piz. Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16. They're exactly the same as they were before. Okay, so I've already tried x equals 1. Well, let's try x equals negative 1 and see what we get there. So this is going to be, now I'm just doing it for just this part over here. Okay, we get negative 1 cubed plus negative 1 squared minus 16 times negative 1 minus 16 is negative 1 plus 1 plus 16 minus 16, which does in fact equal 0. So p of negative 1 equals 0. Therefore, x plus 1 is a factor. Okay, so now how to figure out the other factor? Synthetic division again. So this is a negative 1b value. And we have 1, 1, negative 16, negative 16. 1 comes down. We get 0. Again, we've got a remainder of 0, which is what we're expecting. So we have x minus 1, x plus 1. Then we have x squared, 0x minus 16. And this is now a difference of squares, so we can factor this guy. Okay, so this would be the fully factored version of this guy over here. Okay, now I know this is a bit of a longer question, but I don't think it's harder. Okay, so there's definitely more steps like that, right? But it's the same steps that we're doing before. You just have to do it twice in this question. Okay, so for example 5, it's very similar to the example we did previously, but it's a bit harder because my first term is now a 6x cubed. So if I'm trying to go like this, My question is, what could these numbers be? Is it possible to go like this? Yes. Is it possible to go like this? Yes. Okay, so we have possibilities for these first terms now in order to get a 6x cubed. Now we know that these numbers here have to be factors of the constant term. Okay, so in other words, these numbers, so here, here, and here, have to be factors of the leading coefficient, and these numbers here have to be factors of the constant term. Okay, so when we're doing this, is 2x plus 1 a possible or a potential factor? Yes, because 1 is a factor of 6, 2 is a factor of 6. Is 3x minus 2 a potential factor? Yes. This 3 is a factor of the leading coefficient. This 2 is a factor of the constant term. Okay, so I'm not going to write out the rational zero theorem, but it says the same. But like, if we have a leading coefficient other than 1, we may need to account for other factors like that. All right, let's do this question over here, and we're going to do it the exact same way that we did the other one. What are our potential integral zeros? Okay, well, we have plus or minus 1, plus or minus 2, plus or minus 3, or plus or minus 6. Okay, what are our potential rational zeros? Okay, this is the exact same thing, but now since 2x minus 3 is a potential factor because 2 is a factor of the leading coefficient, 3 is a factor of the constant, that means 3 over 2 is a potential zero. Okay, well, what we have here, 3 came from here, 2 came from here. Okay, so we have, well, let's write them all out. That's possible. This is possible. And this is possible. Okay, so if I do this, that means, what are my potential rational zeros? Well, I could have 1/2, positive or negative. I could have 3/2. Okay, that's this one over here. Now, if I look at these other ones, we've already accounted for this one, because this one over here, what makes this guy 0? Well, 3 does. What makes this guy 1 does. We've already counted for those as 3 and 1 over here. Okay, if I look at my 3x minus 1, 3x minus 2, 3x minus 3, or 3x minus 6 factors. Well, I've already done this one because this is an x equals 1, this is an x equals 2, but this would give me plus or minus 1/3 or plus or minus 2/3. Okay, if I looked at 6x minus 1, 6x minus 2, 6x minus 3, 6x minus 6. Well, I've already done this one because this is x equals 1. This is x equals 1/2. I've already covered that one right here. This is x equals 1/3. I've already covered this one over here. So I need to include a plus or minus 1/6 for this one over here. Okay, guys, I know this may seem very, very complicated. Very rarely do we ever need to start testing these guys over here. Okay, I'm going to say you guys need to know what the rational zero theorem says, but it's coming from ideas like this. Okay, but really, if you test the integral zeros, you're going to get an answer almost every single time. Okay, so let's go back and start testing these integral zeros here. Okay, what is p of 1? I'm going to use my calculator for this. I get negative 10. Did not work. Let's try p of negative 1. It gives me 12. Let's try p of 2. P of 2 equals 0. Therefore, x minus 2 is a factor. Okay, all right. So let's use my synthetic division next. 2. 6, -5, -17, and 6. 6 comes down, I get 12, 7, 14, -3, -6, 0. That was very quick, but we're just using the same synthetic division skills that we talked about earlier on. So we have x minus 2, and then we have 6x squared plus 7x minus 3. Okay, so how is this guy going to work over here? So now we need to be able to factor out this guy over here. Now this could be a bit of work because this one is not a super obvious one to factor, but let's see what we get. I think this one's going to be, how do we multiply to make 6x squared? Well, I think we're going to 3x and a 2x. Okay, so that works here. And I think if I go a positive 3 and a negative 1, it's going to work. So 3x times 2x is 6x squared. 3x times 3 is 9x. Minus 2x gives us a 7x, and then minus 3. Okay, so this is how this guy works, like that. Okay. All right, guys. I hope that this is kind of making sense. Okay, I know this is definitely a more difficult lesson to learn online. So hopefully you guys are in class and you guys are picking this up from either me or your other teacher in school as well. Guys, if you have any questions, please send me an email, and I'll see you guys in the next video. Talk soon.